In the second portion of this, we're going to work on mostly like the quotient rule and maybe see a combination of a few. So for example, the first one says 6 to the fifth over 6 to the third. Okay. Now, if you remember, the quotient rule was saying that if we had the same base and as a refresher, this would be our base. Let me go back real quick. This was our base, and then these are our exponents. So if we have the same base, what we can do is we can just simply subtract the exponents, right, which would be 6 squared. Or if you want to leave this as 36, you can too as well, but for the most part, we'll leave it here, right? And more of a visual to see this, this is basically saying we're taking the number 6 and then we're going to multiply it by itself this many times, right? So 1, 2, 3, 4, 5, and then on the bottom, we'll have 1, 2, 3, right? And when we cross them out, top and bottom, top and bottom, top and bottom, you'll see that we have 6, or I should say 2 6s left on top. And so we get the exact same answer, 6 to the second power. Okay, so this is more of the longer way to do it. And once you understand how it works, I guess, behind the scenes, then applying the rules and the properties becomes a little bit more easier. It becomes a little bit more natural as well. So like x to the fourth and x to the seventh, if we apply the same knowledge where we have the same base, which is x, and we have the exponents here and we're dividing, then we know we can say that this is x to the 4 minus 7, right? Same way as we had 5 minus 3 here, top minus the bottom. And 4 minus 7 is not 3, but it's negative 3. Okay, so here we applied the quotient rule, and then we got left with something that's it's correct but not really acceptable. So here we have a negative exponent, right? Now if we have a negative exponent, that tells us immediately that we need to use the fourth rule that we had here, which was the negative exponent rule. Now, if you just to go back and recall that, right? If we have a negative exponent, we put the entire thing over 1. Okay, if it's on top, if it's just by itself, and then we flip it, and in the process of flipping, you'll see that this negative 2 became a positive 2. Okay, so going forward and just applying it here, this is the same thing now. We're saying x to the negative 3, but we're putting this over 1. Then we're going to flip it, and this becomes 1 over x to the positive 3. Okay, and this would be considered an appropriate final answer. All right, now another way to do this as well, if we had done it out the longer way, you'll see that it also still works if we have 4 x's on top and then 7 of them on the bottom. 1, 2, 3, 4, 5, 6, 7. And if you cross 1 out on top and bottom, 1 on the top, 1 on the bottom, 1 on the top, 1 on the bottom, 1 on the top, 1 on the bottom, and you'll see that we have as a final answer 1 over, right? Because if there's nothing on top, I can't leave it blank because we do have something on the bottom. So I just put a 1 here. Because really, when you say x divided by x, right, we're dividing them, and that's really just a 1. But we just don't write it all the time. Unless we have nothing to write on top, then we have to include this 1 over x to the third, since x times x times x is x to the third. Okay, moving forward here as well. Okay, I'm sure you could probably guess which rule this is. This is the 0 rule. So anything raised to the 0th power is just going to be 1. All right. Moving on to a couple other examples here. We have negative times 9x raised to 0. Now this is what I was talking about before, where we were saying like what's being raised to the 0. Don't automatically look and say, oh hey, there's a 0, that whole thing is just 1, because it depends on what we're doing. So for example, everything inside this parentheses, I call it this quantity, everything there, that is equal to 1. So that is definitely 1. And I'm going to actually drop down these parentheses, okay? And then this negative sign that was in the front, this has nothing to do with this exponent. So this actually drops down as well. So our final answer just ends up being negative 1. Okay, I'm actually going to put a star here because that's pretty important. And it's very easily overlooked. And so that's something we need to watch out for.